The only sound is the rhythmic, mechanical hum of the oxygen scrubbers and the occasional, unsettling groan of titanium adjusting to the squeeze. Inside the sphere, the air is thick, cold, and smells faintly of condensation and recycled breath. Outside, there is nothing. No sunlight, no starlight, no reference points to tell you which way is up or down. Just an endless, crushing void that presses against the three tiny viewports with the weight of an entire ocean. The 4th of December 2000. The Mid-Atlantic Ridge. We are 800 meters beneath the surface of the Atlantic Ocean, sealed inside the DSV Alvin, a tiny titanium bubble drifting through the midnight zone. It is a place where humans were never meant to exist. Here, the pressure is 80 times greater than it is at the surface. It is enough to crush a car into a piece of scrap metal the size of a suitcase. It is enough to compress the very air in your lungs if you were exposed to it for even a fraction of a second. But inside the submersible, 3 people are huddled together, knees cramping, staring out into the blackness, waiting for the seafloor to rise up and meet them. They are tired. The dive is nearing its end. The team, led by researchers from the Scripps Institution of Oceanography and Duke University, had been trailing a camera system across the Atlantis Massif, a massive undersea mountain that rises from the depths like a submerged Everest. They weren't looking for monsters. They weren't even looking for what they were about to find. They were scanning for hydrothermal vents, those violent, black smoking chimneys that spew superheated water and toxic minerals into the ocean, fueling the strange, alien ecosystems that cling to the volcanic spines of the planet. But they were far away from the volcanic axis, miles from where the geological models said any activity should be. By all conventional logic, this part of the mountain should have been dead, a silent, barren graveyard of rock and sediment, sleeping in the dark. But the ocean has a way of laughing at logic. As the pilot maneuvers the submersible over a ridge, the external lights cut through the gloom, pushing back the heavy curtain of water, and then they see it. It doesn't look like geology. It looks like a ruin. Rising from the darkness are towering, ghostly white monoliths. They are not the jagged, black chimneys typical of deep-sea vents. These are intricate, pale spires that twist and soar toward the surface, like the wax dripping from a giant candle, or the spires of a submerged, melting cathedral. Some of them are massive, reaching 60 meters into the water column, the height of a 20-story building. Looming over the tiny submersible like ancient sentinels, they are brilliant white, stark against the eternal black of the deep, glowing in the submersible's headlights as if they possess an inner light of their own. The researchers inside the sphere fall silent. They are staring at a landscape that defies every map they have, every expectation they brought with them, and perhaps every assumption science has made about the ocean floor. This is not a volcanic vent. The water shimmering around these towers isn't the boiling, acidic soup found elsewhere. It is something else entirely. It is silent, it is strange, and it is undeniable. They name the largest structure Poseidon, after the god of the sea, because it feels less like a geological feature and more like a monument. But as the Alvin glides closer, hovering around the delicate flanges of limestone that jut out from the towers, the crew realizes they haven't just found a new rock formation. They have found a city, a ghost town of vents and chimneys stretching across the massif, silent and white, and teeming with secrets that have been locked away for tens of thousands of years. This is the Lost City Hydrothermal Field, and its discovery didn't just add a dot to a map. It shattered the timeline of life itself. Normally, when we think of the deep ocean, we think of it as a place of death, or at best, a place of survival against the odds. We picture the crushing dark, the freezing cold, the scarcity of food. We imagine that life down here is clinging to the edges, fighting a desperate battle against a hostile universe. But what the lights of the Alvin revealed that day in December was not a battlefield. It was a cradle. The white towers of the lost city are not formed by the violent heat of magma, but by a quieter, cooler, chemical reaction between seawater and rock, a reaction that produces heat, hydrogen, and simple organic molecules, the very building blocks of life. For years, scientists had theorized that such places might exist. They had written papers and built models, suggesting that life on Earth might not have started in warm surface ponds under the sun, but in the dark, chemical warmth of places exactly like this. But until that moment, suspended in the dark of the Atlantic, no one had ever seen one. Now, staring out the viewport, they were looking at a window into the deep past, a place that looked less like modern Earth and more like the early oceans of 4 billion years ago, or perhaps like the hidden oceans beneath the ice of Europa or Enceladus. But as the initial awe of the discovery settles, a deeper, more unsettling realization begins to take hold. If this place exists here, so far from the volcanic fires we thought were necessary for such energy, then the ocean floor might not be a desert interspersed with rare oases. It might be riddled with these hidden cities. It suggests that the recipe for life is not rare, but common. It suggests that the darkness is not empty, but waiting. And it suggests that we have been looking for the origins of life in all the wrong places. The lost city is beautiful, yes. It is spectral and haunting, a white mirage in a black desert. But it is also terrifying in its implications, because if a place like this can hide in plain sight, sitting quietly on a mountain we thought we understood, what else is down there? What other geologies? What other chemistries? What other forms of existence are waiting in the 95% of the ocean we have never seen? We like to think we have mapped our world. We have satellites that can read a license plate from space and drones that can fly into hurricanes. But the moment the lights of the Alvin hit those white towers, we were reminded of a humbling truth. The Earth still keeps secrets from us. Massive, towering, paradigm-shifting secrets. Tonight, we are going back to that moment of discovery. We are going to descend past the reach of the sun, past the blue and into the black, to walk the streets of this submerged metropolis. We are going to explore why these white towers are rewriting the textbooks on biology, why they have caught the attention of NASA in the search for extraterrestrial life, and why, despite their beauty, they force us to confront the uncomfortable possibility that we are strangers on our own planet. So, make yourself comfortable, slow your breathing, let the noise of the surface world fade away, replaced by the quiet, heavy hum of the deep. The pressure is building, the light is fading, and the gates of the lost city are opening. Because the story written in this limestone is older than humanity, older than the continents. And it is a story that is still being written in the dark, patiently waiting for us to learn how to read it. Far out in the middle of the Atlantic Ocean, where the water turns a deep, bruised indigo and the horizon stretches into an infinite, unbroken line, there is a mountain. It is not a mountain that anyone will ever climb. It does not scrape the sky or catch the morning sun. It sits alone in the darkness, drowning under 700 meters of crushing salt water, hidden from the eyes of history for millions of years. This is the Atlantis Massif. It is a hulking, silent giant. A massive dome of rock, forced up from the deep interior of the planet, exposing the Earth's mantle to the cold embrace of the sea. To understand why the discovery made here in the dying days of the year 2000 changed everything we thought we knew about our own planet, you first have to understand the silence of this place. It is not the silence of an empty room. It is a heavy, physical silence. The kind of silence that presses against the hull of a ship and squeezes the air out of your lungs. It is a place where the map was supposed to be finished. We thought we understood the mid-Atlantic ridge. We thought we knew how the ocean floor worked. We believed that hydrothermal vents, those underwater geysers that breathe heat and life into the abyss, could only exist in one specific way. We thought they had to be violent, born of fire, sitting directly on top of fresh volcanic magma, spewing black, acidic smoke into the water. We called them black smokers, and for decades they were the only monsters we knew. But the Atlantis Massif is different. It sits 15 kilometers away from the active volcanic rift. It is old rock, cold rock. By all the rules of geology written in the 20th century, this mountain should have been dead. It should have been a silent tomb of peridotite and basalt, sleeping in the dark. It is December 4th, 2000. The research vessel Times Atlantis Times is drifting on the surface, a tiny speck of white steel against the heaving grey ocean. Below it, dangling on a tether miles long, is the Times Argo 2 asterisk, a remotely operated camera sled. In the control room, the air is stale, smelling of coffee and warm electronics. It is the end of the shift. The scientists are tired. They are watching the monitors with the glazed, hypnotic stare that comes from hours of looking at nothing but grey mud and black water. They are not looking for anything spectacular. They are here to study the rock, to map the mountain, to do the quiet, unglamorous work of geology. On the screen, the seafloor is a monochrome wasteland. Silt, rock, silt. The rhythmic monotony of the abyss. The Times Argo 2 Times glides silently, its lights cutting a narrow tunnel through the eternal night. And then, the darkness breaks. It doesn't happen with a roar or a sudden movement. It happens like a dream shifting. One moment, there is only mud. The next, white shapes begin to materialize in the gloom. Ghostly, pale, they rise from the seafloor like the ruins of a sunken cathedral. Spires, towers, columns of blinding white limestone reaching up into the black water. They are not the jagged, dark chimneys of the black smokers. These are intricate, delicate, towering structures that look less like geology and more like architecture. They look like wax dripping from a giant candle, or the stalagmites of an ancient cave, but on a scale that defies logic. In the control room, the boredom vanishes. Chairs scrape against the floor. People lean in, squinting, trying to make sense of the grainy images flickering on the screens. Is it a trick of the light? Is it a camera glitch? The sled moves closer, and the scale becomes apparent. These are not small rocks. Some of them are massive. One structure, later named Poseidon, stands 60 meters tall, the height of an 18-story building looming in the darkness. Utterly silent, utterly white. They had found the lost city. It was a discovery that shouldn't have happened. It was an anomaly that broke the rules. And in the years that followed, from that first glimpse in 2000 to the return expeditions in 2003, the Lost City Hydrothermal Field would go from being a geological curiosity to something far more profound. It would become a place that terrified researchers not because of what it times did asterisk, but because of what it times meant asterisk. It meant that for decades, we had been looking for life in all the wrong places. It meant that the recipe for a living planet was simpler and stranger than we had ever dared to imagine. The terror of the lost city is a quiet terror. It is the terror of realizing how little we actually know. When the scientists first maneuvered their submersibles around these white towers, they expected heat. They expected the violent, scorching temperatures of the black smokers, which can reach 400 degrees Celsius, hot enough to melt lead. But the water here wasn't boiling. It was merely warm. Shimmering waves of fluid drifted lazily from the tops of the spires, mixing with the cold seawater like heat rising from pavement on a summer day. And the chemistry was wrong. Black smokers are acidic, with a pH similar to vinegar or lemon juice. They are toxic, aggressive environments. But the fluids venting from the lost city were alkaline. They had a pH of 9 to 11, similar to soapy water or household ammonia. This wasn't volcanic energy. This was something else entirely. It is a process called serpentinization. And it is, perhaps, the most important chemical reaction in the solar system. Imagine the rock of the Earth's mantle. Dark, green, heavy rock called peridotite. It is rich in iron and magnesium, and it yearns for stability. When this rock is forced up from the depths and exposed to seawater, it becomes unstable. It begins to change. The water attacks the rock, invading its crystal structure, breaking it down, and transforming it into a new mineral called serpentine. But this is not a passive change. It is violent on a molecular level. The reaction releases heat, immense amounts of heat, without a single drop of lava. It releases hydrogen gas. It releases methane. It creates a chemical soup that is warm, energy-rich, and chemically active. This is what was happening inside the Atlantis Massif. The mountain was effectively burning underwater, fueled not by fire, but by water itself. And as this warm alkaline fluid seeped out of the sea floor and met the cold, calcium-rich seawater, it precipitated instantly. It turned to stone, layer by layer, year by year, century by century. The fluid built these towering white chimneys: Poseidon, the IMAX Tower, the Nature Tower, monuments to a chemical reaction that has likely been happening since the oceans first formed. But the true shock came when they looked closer, when the submersible Alvin descended to the field in 2003. The pilots and scientists peered out of the small viewports, their breath fogging the glass. The lights illuminated the white spires, turning them into glowing monuments against the absolute black of the deep. And they saw that the city was not empty. It was teeming, but it was teeming in a way that was almost invisible. There were no giant tube worms with blood-red tips like the ones found at volcanic vents. There were no swarms of giant clams. Instead, the life at Lost City was ghostly. Transparent shrimp crawled over the carbonate spires, their bodies so clear you could see their internal organs beating. Tiny crabs scurried into crevices. But the real life, the biomass that mattered, was the slime, biofilms. Thick, gelatinous strands of bacteria and archaea, draping the towers like cobwebs in a haunted house. They coated the inside of the chimneys, clogging the vents, thriving in the warm alkaline fluids. These microbes didn't need the sun. They didn't need oxygen. They didn't even need volcanic carbon. They were eating the hydrogen and methane produced by the rock itself. They were living on the energy of the earth, reacting with water. This is where the awe turns into an existential shiver. Because if life can exist here, fueled only by rock and water, then life does not need a miracle. It does not need a perfect, sunlit planet. It does not need a volcanic spark. It just needs a wet rock. And the universe is full of wet rocks. As the Alvin hovered there in 2003, collecting samples with its robotic arms, breaking off pieces of these fragile white cathedrals, the researchers began to understand the implications. They were looking at a window into the deep past. This quiet, alkaline, hydrogen-rich environment was likely the cradle of life on Earth. Before there was photosynthesis, before there was oxygen, there was serpentinization. The chemical energy provided by these vents is exactly the kind of push needed to turn simple molecules into the building blocks of biology. We weren't just looking at a geological oddity, we were looking at our own nursery. But the mirror reflects outward too. The realization hit the scientific community with the force of a physical blow. If this process creates the conditions for life here, what about elsewhere? We know that Enceladus, the tiny frozen moon of Saturn, spits plumes of water into space that contain the chemical signatures of serpentinization. We know that Europa, Jupiter's icy moon, has a rocky mantle in contact with a vast saltwater ocean. The Lost City proved that you don't need a sun to have a biosphere. You don't need to be in the Goldilocks zone. You can be in the freezing dark of the outer solar system beneath 10 kilometers of ice. And if you have rock and water, you might have a lost city of your own. You might have towers of white carbonate rising in the dark. You might have biofilms. You might have life. It is 2003, and the Alvin is ascending. The lights of the lost city fade beneath the submersible, swallowed once again by the crushing darkness. The white towers of Poseidon are left behind, standing vigil in the silence as they have for at least 30,000 years. Inside the sub, the researchers are quiet. There is a sense of trespassing, a sense that they have stumbled into a temple that wasn't built for them. The samples they carry up to the surface, chunks of porous white limestone, vials of warm fluid, scrapes of microbial slime, will keep laboratories busy for decades. But the data is almost secondary to the feeling that the Earth is stranger than we gave it credit for, the feeling that the ocean floor is not a graveyard, but a battery. And there is something else, a nagging fear that comes with the territory of discovery. The lost city is fragile. The towers are made of carbonate, the same material as seashells and coral. They are brittle. A misplaced thruster blast from a submersible can topple a spire that took 1,000 years to build. We had found this place, yes, but in finding it, we had also endangered it. We had put it on the map, and on a planet where resources are scarce and curiosity is boundless, being on the map is a dangerous thing. The anomaly on the Atlantis Massif sits there today, right now, as you listen to this. The shrimp are crawling over the white stone. The warm fluids are shimmering into the cold dark. The hydrogen is bubbling out of the rock. It is a lonely, alien world, right here on our own planet. It is a reminder that we are not the masters of this rock. We are tourists. We are late arrivals, and the systems that keep this planet alive, the deep, slow, chemical heartbeats of the Earth, were beating long before we arrived, and they will continue to beat long after we are gone. But the story of the lost city doesn't end with its discovery. In fact, the discovery was just the opening of a door, and what walked through that door was not just wonder, but a new kind of hunger, because where there are rare minerals, where there are unique biological codes, where there are secrets held in stone, there are also eyes that see value. The silence of the Atlantis Massif was broken by the Times Argo 2 times and the Times Alvin asterisk, but they were scientific vessels. They came to learn. But the ocean is vast, and the laws that govern it are thin. As the years passed after that 2003 expedition, the lost city sat in the crosshairs of a conflict that no one on that ship could have fully predicted. A conflict between the desire to understand our origins and the drive to exploit them. But before we face the modern threat to this white cathedral, we have to go deeper into the chemistry itself. We have to look at the invisible architecture of the place, because the reason the lost city terrifies researchers isn't just because it's beautiful or because it's old. It's because the chemistry inside those vents is doing something that borders on magic. It is creating organic matter from stone, and that magic is what draws us back, again and again, like moths to a flame that doesn't burn. Imagine the fluid rising through the throat of the chimney. It starts deep in the crust, as seawater, cold, heavy, full of oxygen. It sinks down through cracks in the seafloor, kilometers down, until it meets the warm, fresh mantle rock. And there, in the high-pressure dark, the transformation happens. The water strips the rock of its identity. It pulls out hydrogen. It pulls out methane. It becomes light, buoyant, and desperate to escape. It races back up toward the surface, carrying its stolen energy. When it hits the open ocean water at the vent opening, the change is instant. The fluids mix. The chemistry crashes. Carbonate minerals fall out of the solution like snow, building the walls of the chimney, sealing the reaction away from the sea. And inside those porous walls, in the tiny microscopic chambers of the rock, the magic happens. The hydrogen and the carbon dioxide dance together, catalyzed by the minerals, forming simple organic molecules, formate, acetate, the precursors of life. This is the abiotic synthesis of organic compounds, a dry scientific phrase for a miraculous reality. The Earth can make food out of rocks. It doesn't need plants. It doesn't need sunlight. It creates the fuel for life from the geology itself. This is why the researchers stare at the monitors with such intensity. This is why the silence of the control room feels so heavy. They are watching the planet act like a living thing. They are watching the boundary between the living and the non-living dissolve. In the lost city, the rock is not just a stage for life. The rock is the mother of life. And the spires themselves? They are huge. Poseidon is the most famous, a multi-spired giant that looks like the melted ruins of a Gothic castle. But there are others. There is the IMAX Tower, standing 30 meters tall, with a flange of rock sticking out of its side like a diving board. Underneath that flange, pools of warm water collect, creating upside-down lakes of venting fluid where life congregates. The ecosystem is inverted. The crabs and shrimp hang upside down, grazing on the bacterial mats that coat the ceiling of the rock overhang. It is a world turned on its head. The colors are subtle but striking. The rock is blinding white, but where the bacteria grow, it turns shades of creamy yellow, light brown, and pale pink against the unrelenting black of the deep ocean. It looks spectral. It looks like a ghost town, but it is the most alive place for miles. The surrounding seafloor is a desert of basalt and sediment, sparse and quiet. But here, within the influence of the vents, the density of life is staggering. It is an oasis in the abyss. But unlike the black smokers, which might last only a few decades before their volcanic plumbing gets clogged or the magma shifts, the Lost City is ancient. Carbon dating of the majestic white towers shows that this field has been active for at least 30,000 years. 30,000 years of continuous chemical synthesis. 30,000 years of life clinging to these spires in the dark. That stability is key. It means that life here has had time to evolve, to adapt, to become specialized. It means this isn't a fleeting spark. It's a steady flame. And yet, 30,000 years is a blink of an eye in geological time. The underlying process, the serpentinization of the mountain, has likely been going on for hundreds of thousands, perhaps millions of years. The Lost City we see today is just the current expression of a much older, much deeper phenomenon. It is the tip of the iceberg. The entire Atlantis Massif is a reactor. During those early expeditions, the scientists worked around the clock. The Times Atlantis Times doesn't sleep. The sub goes down in the morning, spends 8 hours in the deep, and comes up in the evening. Then the dredging baskets go down. Then the camera sleds. The cycle of discovery is relentless. But every time the samples came up to the deck, there was a moment of hesitation, a moment where the crew would gather around the buckets of white rock and clear water. There is something humbling about holding a piece of the earth that shouldn't exist. The rock of the chimneys is fragile. On the seafloor, it is strong enough to stand 60 meters tall, supported by the buoyancy of the water. But on the deck of the ship, it feels light, almost like styrofoam or pumice. It crumbles easily in the hand. It is a reminder of how delicate this environment is. It is a cathedral made of spun sugar, standing in a hurricane of time. And the smell, when the samples of the vent fluid are opened in the lab, they don't smell like the sulfurous, rotten egg stench of the black smokers. They smell faint, organic, almost sweet. It is the smell of hydrogen and hydrocarbons. It is the smell of raw potential. The researchers catalogued everything. They counted the pores in the rock. They sequenced the DNA of the slime. They measured the isotopes of the carbon. They built a picture of an ecosystem that operates on a completely different set of rules than the world we live in. They found that the archaea inside the vents, ancient, single-celled organisms, were dominating the system. These are the methanosarcinales, microbes that produce methane, and the methanococcoles, microbes that eat it. A closed loop of consumption and production, cycling energy in the dark, entirely cut off from the sun. This isolation is profound. The genetic codes found here are unique. They have drifted away from their surface relatives, evolving in solitude for eons. If we were to lose this place, we wouldn't just be losing a geological feature. We would be losing a biological library. We would be burning a book we haven't even learned how to read yet. The return trip in 2003 solidified the fear. The sheer uniqueness of the Lost City became its vulnerability. It wasn't one of many. At the time, it was the only one of its kind ever found. Since then, We have found hints of others, chemical traces in the water, but the lost city remains the type specimen, the original, the masterpiece, and because it sits on top of the Atlantis Massif, a mountain made of mantle rock, it is essentially a wound in the Earth's crust that refuses to heal, and that wound is bleeding energy. The narrative of the lost city is a narrative of paradoxes. It is rock, but it acts like biology. It is deep, but it affects the surface. It is old, but it teaches us about the new, and it is terrifying because it forces us to admit that the Earth is not finished. It is still creating. It is still experimenting. Down there in the dark, the planet is cooking up new recipes for life, just as it did 4 billion years ago. As the Atlantis Times turned back toward port in 2003, leaving the massif behind, the scientists knew they were leaving a piece of their souls in the deep. They knew that they had seen something sacred, not in a religious sense, but in a planetary sense. They had seen the engine room of existence, but the ocean is a hiding place for many things. And as the 21st century marched on, the isolation that protected the lost city began to erode. Not by natural forces, but by human ones. The map was no longer blank. The coordinates were known, and the very minerals that make the Atlantis Massif so fascinating to scientists, the metals, the rare earth elements, the sheer volume of accessible mantle rock began to look very different to other eyes. They began to look like assets. The terror researchers feel today is not just philosophical, it is practical. It is the terror of watching a bulldozer approach a library. It is the terror of knowing that the slow, silent work of 30,000 years can be undone in a single afternoon of industrial violence. But to understand that threat, we have to understand what happened next. We have to leave the years of discovery behind and enter the era of scarcity. The era where the bottom of the ocean became the next frontier for the hungry machines of the surface world. But in those quiet years between 2000 and 2003, there was a brief moment of pure, unadulterated wonder, a moment where humanity looked into the abyss, and for the first time, the abyss didn't look back with teeth and fire. It looked back with white towers and silence. It looked back with a ghost of our own beginning, and in that silence, we heard the whisper of a universe that is far more alive than we ever dared to hope. The Atlantis Massif sleeps in the indigo dark. The towers of Poseidon stand watch. The fluids shimmer. The crabs scuttle. The bacteria eat the rock, and the world turns, unaware that its deepest secret has been found and that the clock is ticking on its solitude. The anomaly is no longer just a scientific puzzle. It is a test of whether we can value what we do not own. A test of whether we can let the darkness keep its secrets, or if, in our hunger to know and to take, we will turn the lost city into truly lost history. The lights of the submersibles fade. The cables are reeled in. The ship sails away. But the connection is made. We know it is there now. And once you know a thing exists, you can never truly unknow it. The innocence of the empty map is gone. The white towers are etched into our collective memory, standing there in the deep, waiting for whatever comes next, waiting for us to decide if they are a temple to be revered or a mine to be stripped. The silence of the deep is heavy, but the silence of a future without the lost city would be heavier still. It would be the silence of a world that forgot where it came from. This is the legacy of those early expeditions. They gave us a gift, and they gave us a burden. They showed us that we are not alone on this rock, that the rock itself is alive with potential, and they left us with the terrifying realization that the most alien world we will ever visit is the one we are standing on right now. The anomaly on the Atlantis Massif is not just a place on a map, it is a question mark at the end of the sentence of human knowledge, and we are still waiting for the answer. To understand why the Lost City Hydrothermal Field sends a shiver through the spine of the scientific community, we first have to let go of the ocean we think we know. We have to forget the sunlit reefs where fish dart through coral. We have to forget the crushing, abyssal plains that stretch like deserts across the bottom of the world. We even have to forget the violent, roaring black smokers that we spent decades studying, assuming they were the only engines of heat in the deep. We have to descend to the Atlantis Massif, a mountain that should not exist, rising from the seafloor in the middle of the Atlantic Ocean. And there, amidst the eternal night, we have to look at a chemical reaction that is so quiet, so slow, and yet so relentless that it changes the way we understand the history of life itself. Between the years 2004 and 2010, a series of expeditions and studies began to peel back the layers of this mystery. They returned to the site, not just to map it, but to listen to it, to taste the water that flowed from its white, ghostly chimneys, to read the code written in the rock. And what they found was a process that felt less like geology and more like the breathing of a sleeping god. A process known as serpentinization. It is a word that sounds ancient, almost mythological, and, in a way, it is. It refers to the green serpent, the rock known as serpentinite, which forms the foundation of the Lost City. But the rock doesn't start that way. It begins as peridotite, a dense, dark, iron-rich stone that belongs deep in the Earth's mantle, kilometers below the crust. It is the heavy stuff of the planet's interior, never meant to see the ocean. But the Atlantis Massif is a wound in the Earth's skin. Through tectonic stretching and faulting over millions of years, the crust ripped open, and this mantle rock was heaved upward, exposed to the cold, crushing weight of the seawater. And that is where the magic and the terror begins. When seawater seeps down into fractures in this mantle rock, it doesn't just sit there. The rock is unstable. It is out of equilibrium with the ocean. It yearns to change. The water molecules, driven by gravity and pressure, work their way deep into the faults, reaching down maybe a kilometer or more. There, in the dark, the water meets the fresh peridotite, and a reaction triggers. It is not a reaction driven by magma. There is no volcanic fire down here. There is no molten chamber powering the system. It is simply rock and water, meeting in the dark, and changing one another. The water attacks the rock. It strips away oxygen. It hydrates the minerals, and in doing so, the rock releases heat. A lot of heat. It is an exothermic reaction, a chemical fire that burns without flame. The water warms up, rising to temperatures of 90 degrees Celsius, sometimes higher. It becomes buoyant. It begins to climb back up through the cracks, carrying with it a cargo of dissolved chemicals. But the water that returns to the surface is not the same water that went down. It has been transformed. It has been stripped of its magnesium. It has been enriched with calcium. And most importantly, it has been loaded with hydrogen. This is the serpent's breath. Hydrogen gas. Raw chemical energy. The fuel of the universe, generated not by a star, but by a wet rock in the dark. As this warm, hydrogen-rich fluid rises and vents into the cold, oxygenated seawater, it hits a barrier of chemistry. The fluids are incredibly alkaline, with a pH of 9 to 11. That is the same pH as household ammonia or liquid drain cleaner. When this caustic, high pH fluid meets the seawater, which is slightly acidic by comparison, the reaction is instantaneous. Minerals precipitate out of the water immediately. Calcium carbonate, limestone, the same material that makes up seashells and coral reefs, but here it forms spontaneously without the aid of biology. This precipitation builds the towers, layer by layer, molecule by molecule. The chimneys grow. They are not the jagged, iron-rich sulfides of the black smokers, which grow and collapse in the span of a human decade. These are white, porous, intricate structures. They are cathedrals of carbonate. They are delicate, yet massive. The structure, known as Poseidon, stands 60 meters tall, a ghostly skyscraper in the abyss. And unlike the black smokers, which might burn out in 50 years, the lost city has been venting for at least 120,000 years. 120,000 years. Pause for a moment and feel the weight of that number. 120,000 years of continuous chemical breathing. When humans were still learning to make stone tools, the lost city was here, venting into the dark. When the ice ages came and went, freezing the surface of the world, the lost city was here, warm and constant. While empires rose and fell, while civilizations built their own cities of stone and mortar, this city of carbonate continued to grow in the silence of the mid-Atlantic. It is a stability that defies our understanding of the deep ocean. And it was during those critical years, from 2004 to 2010, that researchers realized what this stability meant. They weren't just looking at a geological oddity, they were looking at a battery, a planetary-scale battery that runs on water and rock. This realization brought with it a sense of unease, because if you have a battery, if you have a source of energy that flows constantly, reliably, for hundreds of thousands of years, and you have water, and you have carbon, then the laws of thermodynamics suggest that something should be there to use it. Nature abhors wasted energy, and something is there. The 2005 expedition to the Lost City, led by a team of scientists aboard the research vessel Atlantis, sent the submersible Alvin down into the dark to take a closer look. Imagine sitting in that small titanium sphere, 3 people cramped together, descending through the blue, then the black, watching the depth gauge tick past 700, 800 meters. Outside, the pressure is immense. The darkness is total. And then, the lights of the sub catch something in the distance. A white spire, looming out of the gloom. It looks like a ghost. It looks like a ruin. It is the Lost City. As the sub glides closer, the pilots have to be incredibly careful. Unlike the black smoker chimneys, which are hard and metallic, the structures here are fragile. If you bump them, they crumble. They are made of stiff meringue, of chalk. The robotic arm of the sub reaches out, delicate as a surgeon, to snap off a piece of the chimney. When they bring those samples back to the surface, when they crack them open in the ship's labs, they find the secret hidden inside. The chimneys are not empty. They are teeming. Inside the porous walls of the carbonate towers, in the tiny labyrinthine spaces where the warm alkaline fluid mixes with the cold seawater, there is a thick, slimy biofilm. It coats the inside of the rock like a skin. But this isn't a collection of animals. You won't find the giant tube worms here. You won't find the swarms of blind shrimp that dominate the black smokers. This is a microbial city. It is dominated by archaea, the ancient, single-celled organisms that represent a branch of life distinct from bacteria and eukaryotes. Specifically, they found methanosarcinales, methanogens, organisms that eat hydrogen and carbon dioxide and breathe out methane. This was the revelation that shook the scientific community. These organisms were not relying on the sun. They weren't even relying on the heat of volcanic magma. They were living entirely off the geological process of serpentinization. They were eating the serpent's breath. The rock reacted with the water to create hydrogen. The microbes ate the hydrogen to create methane. And the methane fed other microbes in a slow, silent chain of life that required nothing from the surface world. It was a completely independent ecosystem. A biosphere built on a chemical reaction that could happen on any wet, rocky planet in the universe. And that is where the terror comes in. Not the terror of a monster, but the terror of an idea. The idea that life is not a miracle, but a consequence. During this period, geochemists like Mike Russell and biologists like William Martin began to refine a theory that had been brewing on the fringes of science. They looked at the Lost City with its warm, alkaline fluids, its honeycombed rock structures, its endless supply of hydrogen, and they saw something familiar. They saw a womb. They proposed that life on Earth didn't start in a warm little pond on the surface, struck by lightning. They proposed it started here, or in a place very much like here, 4 billion years ago. Think about the structure of the chimneys. They are filled with millions of tiny pores, microscopic chambers separated by thin walls of mineral. In the Hadean Ocean, 4 billion years ago, the entire sea was acidic, filled with carbon dioxide and iron. If you had alkaline vents, like the Lost City, bubbling into that ancient, acidic ocean, the difference in pH across those thin mineral walls would create a natural electrical charge, a proton gradient. It is the same exact mechanism that powers every living cell in your body today. Your mitochondria work by pumping protons across a membrane to generate energy. The Lost City does the same thing, but on a geological scale. The chimney is the cell. The mineral wall is the membrane. The ocean and the vent fluid are the opposing forces. The implication is staggering. It suggests that the machinery of life, the way we generate energy, was invented by the rocks themselves long before the first cell ever existed. The rocks were doing it first. Life just moved in. Biology is essentially rock chemistry that learned to replicate itself. This theory, bolstered by the data coming out of the Lost City between 2004 and 2010, suggests that the spark of life wasn't a spark at all. It was a slow, steady burn, a chemical inevitability. If you have peridotite and you have water, you get hydrogen. If you get hydrogen and carbon dioxide, you get methane. If you have alkaline vents, you get natural electrochemical gradients. And if you let that run for 1 million years, maybe, just maybe, the rock starts to wake up. This terrified researchers because it took away the specialness of the surface. It meant that we are not children of the sun. We are children of the dark. We are the result of a chemical tension deep in the ocean, a tension that the Earth has been trying to resolve for billions of years. But the anxiety went deeper than just the origin of life on Earth. It extended to the stars, because if serpentinization is the engine of life, then the engine is everywhere. In 2005, the Cassini spacecraft swept past Enceladus, a tiny moon of Saturn. It saw plumes of water vapor erupting from cracks in the ice near the South Pole. Analysis of those plumes revealed salts, organic molecules, tiny grains of silica, the fingerprints of hot water touching rock, the fingerprints of serpentinization. Europa, the icy moon of Jupiter, holds a global ocean beneath kilometers of ice. It sits on a rocky mantle. The gravity of Jupiter needs the moon, keeping the interior warm. Water touches rock. Darkness, pressure, time. The Lost City became a mirror. When researchers looked into those white chimneys in the mid-Atlantic, they weren't just seeing Earth. They were seeing a model for the entire cosmos. They were seeing what might be happening right now, this very second, in the dark oceans of the outer solar system. It meant that the universe might be teeming with life, but not the kind of life we look for with radio telescopes. Not civilizations building cities of steel, but silent, microbial biospheres, clinging to the breath of wet rocks, buried beneath miles of ice, utterly unaware of the stars. It is a lonely thought. A universe full of life that can never speak to us. As the decade drew to a close, the data from the Lost City continued to pile up, and the complexity of the site became even more apparent. Carbon dating revealed that, while the active vents were tens of thousands of years old, the underlying fracture system might have been active for hundreds of thousands of years. The system was robust, yet fragile. Scientists found that the fluid chemistry was incredibly stable. Year after year, the ratios of hydrogen to methane remained constant. The temperature held steady. The serpent was sleeping soundly, breathing with a rhythm that defied the chaos of the surface world. But they also found that the ecosystem was delicate. The microbes were slow growers. In the cold, energy-poor environment of the deep sea, life does not rush. It endures. Some of these organisms might divide only once every few months, or even years. They live life in slow motion. This introduced a new kind of fear, the fear of human intrusion. The lost city is not protected by distance anymore. As technology advances, the deep ocean becomes accessible. Mining companies began to look at the seafloor with hungry eyes, not necessarily for the carbonate of the lost city, but for the sulfides of the black smokers and the manganese nodules of the plains. But the lost city stands as a unique heritage site. If we were to damage it, if a trawler dragged a net through it, or a mining operation disturbed the fluid flow, we wouldn't just be breaking some rocks. We would be smashing the only working model we have of the origin of life. We would be erasing the library before we have finished reading the first book. The physical samples brought up from the depths during these expeditions sit in cold rooms in laboratories around the world. They are unassuming chunks of grey and white stone. To the uninitiated, they look like dried cement. But to the geochemists who study them, they are vibrating with information. They hold isotopes of carbon that tell stories of ancient fluids. They hold lipids, fatty molecules produced by microbes that died thousands of years ago, preserved in the tomb of the carbonate. One of the most haunting discoveries came from the analysis of the hydrocarbons. The reaction between water and rock produces methane. Yes, but the researchers found more complex hydrocarbons too. Ethane, propane, butane, the building blocks of oil and gas. But these weren't coming from decayed dinosaurs or ancient forests. They were coming from the rock itself. This abiotic synthesis of organic molecules meant that the Earth is a factory for the ingredients of life. It creates the menu, even if there is no one there to eat. It forces us to ask, is the Earth alive? Not in the biological sense, perhaps, but in a chemical one. Is the planet itself a metabolic system? The line between the living and the non-living, which we like to draw so sharply, begins to blur at the lost city. The rock breathes, the water circulates, the minerals grow, the energy flows. Is a chimney that grows, processes energy, and maintains a chemical gradient really so different from a coral or a tree? We stand on the deck of the ship, looking out at the endless grey waves of the Atlantic, and we feel small. But when we look at the data from the lost city, we feel something else. We feel a vertigo of time. We realize that the ocean floor is not a graveyard. It is a laboratory that has been running an experiment for 4 billion years. And the result of that experiment is us. But the lost city has one more lesson to teach us, perhaps the most unsettling one of all. It is a lesson about the future. The serpentinization process locks away carbon. As the minerals precipitate, they trap carbon dioxide from the ocean and turn it into stone. The lost city is not just a vent, it is a carbon sink. It is part of the planetary thermostat. For millions of years, processes like this have helped regulate the Earth's climate, slowly, patiently sequestering carbon into the crust. It reminds us that the Earth has its own mechanisms, its own controls, which operate on timescales that make our human concerns seem like the flickering of a gnat's wing. We worry about the climate of the next century. The lost city worries about the climate of the next 10 million years. By 2010, the picture was becoming clear, but the mystery was deepening. We knew how times the lost city worked. We knew the chemistry, we knew the biology, but we still didn't truly understand its extent. Was the lost city unique, a freak accident of geology? Or was the seafloor littered with these quiet white cities? The answer matters. If the lost city is unique, then the origin of life might be a rare singular event, a lucky roll of the dice in a hostile universe. But if the lost city is common, if these systems are ubiquitous along the thousands of kilometers of slow-spreading mid-ocean ridges, then life might be an epidemic. The ocean floor might be glowing, chemically speaking, with thousands of these hidden batteries, all pumping out hydrogen, all nurturing their own slow, dark ecosystems. The silence of the deep ocean is deceptive. It is not empty. It is waiting. The researchers who spent those years unlocking the geochemical code returned with more questions than answers. They found that the more they looked at the simple reaction of water and rock, the more complex it became. They found that the fluid pathways beneath the city were like the roots of a great tree, reaching deep into the mantle, drawing sustenance from the very heat of the planet. They found that the microbes were not just passive inhabitants, they were active engineers, influencing the chemistry of the fluids, perhaps even helping to precipitate the chimneys themselves. It is a symbiotic relationship between rock and life, a partnership in the dark. And as we drift away from the specifics of the chemistry, we are left with the feeling that the lost city is watching us. It has been there for 120,000 years. It will be there long after we are gone. It is indifferent to our presence. It does not care if we study it. It does not care if we understand it. It simply continues to breathe. The hydrogen rises. The methane forms. The chimneys grow. In the darkness of the Atlantic Massif, the serpent sleeps, but it never stops dreaming, and its dreams are made of the same stuff that powers the stars and the cells in our own blood. This is why it terrifies us. Because it is so alien, and yet so intimately related to us. It is the face of our mother that we do not recognize. It is the home we left billions of years ago, and looking at it now, we realize how far we have wandered. We live in the light, addicted to the sun, fragile and frantic. But down there, in the crushing dark, the old ways still hold. The slow, steady, chemical burn of eternity. And as the years turned and the first decade of the new millennium ended, the scientists knew that they had only scratched the surface. The lost city had unlocked a door, but the room beyond was vast and shadowed. The code had been read, but the story was just beginning. It was a story that would lead them to rethink the habitability of Mars, the oceans of Europa, and the definition of life itself. But before we ascend from the depths, before we leave the white towers behind, we have to look closer at the darkness that surrounds them. Because the chemical light of the lost city illuminates more than just the rock. It illuminates the vast, unexplored potential of the underground ocean, the aquifer that runs beneath the seafloor, a volume of water that rivals the oceans above. And in that subterranean sea, where water moves through the veins of the earth like blood, the influence of the serpentinization reaches even farther than we thought. The breath of the serpent does not just vent into the ocean. It permeates the crust. It seeps sideways. It travels for miles through the fractured rock, and wherever it goes, it carries the potential for life. We used to think of the seafloor as a barrier, the bottom of the bucket, but the lost city taught us that the seafloor is a filter, a membrane, a place where the planet exchanges matter and energy with the ocean. It is alive. So when you lie in the dark tonight and the silence settles around you, think of the Atlantis Massif. Think of the white spires glowing faintly in the spotlights of a submersible. Think of the hydrogen bubbling up from the mantle. Think of the microbes, eating the rock, breathing the gas, waiting in the cold. They are your ancestors. They are your cousins. They are the keepers of the deep code. And they are still there, right now, while you sleep. The earth is shifting, the water is flowing, and the lost city is building itself, one molecule at a time, in the eternal, crushing patience of the deep. To understand why the lost city is so unnerving, you first have to forget everything you think you know about the bottom of the ocean. We are taught to imagine the deep sea as a place of crushing finality, a graveyard where whale bones drift down into the silt and ships rust into oblivion. We picture the abyss as the end of the line, but somewhere in the middle of the Atlantic, on top of an underwater mountain called the Atlantis Massif, there is a place that suggests the abyss is not a grave. It is a womb, and the things that are happening there, the chemical violence and the silent, shimmering creation, challenge the very story of who we are and where we came from. Between the years of 2011 and 2017, A shift occurred in how researchers looked at this white, ghostly field of towers. It wasn't just a curiosity anymore. It wasn't just a unique ecosystem where crabs scuttled over limestone. It began to look like an engine, a Genesis engine. And as the data came in, as the chemical models were run, and the fluid samples were analyzed, a terrifying possibility began to take shape in the minds of those who study the origins of life. The possibility is that life is not a miracle. It is not a lucky accident that happened once in a blue moon on a blue marble. The possibility is that life is inevitable, that it is a chemical obligation, that if you put the right rocks with the right water under the right pressure, the universe has no choice but to create you. To see this engine at work, we have to descend. We have to leave the sunlight behind, slipping beneath the waves where the blue turns to indigo and the indigo turns to a black, so absolute it feels heavy against the glass of the submersible. We are not heading for the famous black smokers, those violent, magma-fueled chimneys that roar like jet engines and spew superheated, toxic metal into the sea. Those are the celebrities of the deep, the ones that get all the attention. But the Lost City is different. It is quieter, it is older, and it is much, much stranger. As the lights of the remote-operated vehicle sweep across the darkness at 700 meters deep, surprisingly shallow for such a mystery, they catch the glint of something pale. Rising from the seafloor are towers. They are not black or rusty red. They are white, stark, bone-white limestone, soaring up to 60 meters high, like the spires of a submerged cathedral that was never built by human hands. They are ghostly against the eternal night, and unlike the black smokers, which are fueled by the violent heat of volcanic magma, these towers are cold at their core. Or rather, they are fueled by something else. They are fueled by the rock itself. This is the first part of the terror, the realization that the Earth doesn't need fire to create heat. It just needs water and rock. The process is called serpentinization. It sounds like something from mythology, a word that evokes snakes and dragons, and in a way, it is a transformation of mythical proportions. The Atlantis Massif is made of mantle rock, peridotite, which is rich in a mineral called olivine. This rock normally sits deep within the Earth, safe and dry. But here, tectonic faults have torn the crust open, exposing this deep green rock to the seawater. And the rock is thirsty. When seawater touches olivine, it doesn't just get wet, it attacks. The water molecules drive their way into the crystal lattice of the rock, shattering it, hydrating it, changing it from hard peridotite into a softer, greasy green stone called serpentinite. But this is not a passive change. It is a violent, exothermic reaction. The rock gets hot. It releases heat as it changes, enough to warm the water to 90 degrees Celsius, nearly boiling, without a single drop of magma nearby. And as it changes, it releases something else, hydrogen. Gas bubbles of pure chemical energy, liberating themselves from the stone and rising into the ocean. This is the engine. A massive geological battery that has been running for at least 30,000 years, and possibly much, much longer. It is churning out hydrogen gas and methane, the very fuels that microbes love to eat. And it creates a fluid that is strange, almost alien. The water coming out of these white chimneys is highly alkaline, with a pH of 9 to 11. It is soapy, caustic, like liquid drain cleaner. And when this hot, high pH fluid hits the cold, acidic ocean water, it precipitates instantly. It creates limestone. It builds its own chimneys, layer by layer, growing them taller and more complex with every passing year. But the researchers looking at this between 2011 and 2017 saw something more than just chemistry. They looked at the structure of the rocks. They looked at the microscopic pores inside those white chimneys, and they realized they were looking at a blueprint. The chimneys of the Lost City are not solid. They are honeycombs. They are riddled with tiny, interconnected chambers, millions of them. And inside those chambers, the warm, Alkaline fluid from the rock meets the cool, acidic water of the ocean. They don't mix instantly. They swirl, they dance, and across the thin mineral walls of those tiny chambers, a gradient forms. This is where the story shifts from geology to biology. This is where the machine wakes up. In the biological world, in your body right now, your cells are doing something very specific. They are generating energy by pumping protons across a membrane. It is called a proton gradient. It is the universal battery of life. Every living thing on Earth, from the moss on a stone to the whale in the deep to the human listening to this, uses this exact same mechanism to stay alive. We are all just complex ways of maintaining a proton gradient. And for decades, scientists wondered how life learned to do this. How did a primitive cell, billions of years ago, figure out how to build a membrane, pump protons across it, and harness the energy? It is a complex piece of nanotechnology. It seems impossible that it just popped into existence, but the Lost City offers an answer that is as elegant as it is unsettling. Life didn't have to learn how to do it. The rocks were already doing it. The microscopic chambers inside the white chimneys are times the membranes. The alkaline fluid on one side and the acidic ocean water on the other create a natural, geological proton gradient. The Genesis engine isn't just making food. It is providing the physical structure of life before life even exists. The rocks are acting like cells. The chimneys are the first bodies. During those years of intense scrutiny, researchers like Nick Lane and William Martin began to articulate this white smoker hypothesis with startling clarity. They proposed that the first ancestor of all life wasn't a free-floating cell in a soup of chemicals. It was a rock-bound resident of a place like the Lost City. They suggested that 4 billion years ago, when the oceans were different and the atmosphere was toxic, the entire seafloor might have been dotted with these alkaline vents. And in the quiet, dark chambers of those white towers, the chemical gradients were doing the work of biology before biology was ready to take over. Imagine the implication. It means that you don't need lightning strikes. You don't need meteorite impacts. You don't need a warm little pond teeming with magic ingredients. You just need a wet, rocky planet. If you have olivine and you have water, you get serpentinization. If you get serpentinization, you get alkaline vents. If you get alkaline vents, you get the electrochemical gradients that power life. It suggests that the origin of life is a planetary process, as fundamental as plate tectonics or the water cycle. It suggests that life is what planets times do times when they cool down. This removes the romance from our origin story. We like to think of ourselves as special, as the result of a 1 in a trillion roll of the cosmic dice. But the Lost City stares back at us and says, "No, you are a chemical reaction. You are the inevitable result of water seeking equilibrium with rock." It creates a sense of vertigo, a feeling that we are looking into a mirror that reflects a time before time. When researchers steer their ROVs around those white spires, watching the shimmering fluids distort the water, they are not just exploring the ocean, they are exploring the Hadean eon. They are looking at the cradle, and the cradle is active. This is the other aspect that unsettled the scientific community during this period. The Lost City isn't a fossil. It is happening times now. Asterisk. Inside those porous walls, right at this moment, complex organic molecules are being synthesized abiotically. The hydrogen from the rocks is reacting with carbon dioxide in the water to form methane, formate, and hydrocarbons. The building blocks of life are being assembled by the geology itself. It is a factory, and it runs in total silence, in total darkness, indifferent to the world above. The creatures that live there now are merely the squatters in this ancient machine. There are tiny amphipods, translucent and pale. There are gastropods, snails that graze on the bacteria mats. There are crabs that pick their way delicately across the limestone. But they are not the main event. They are the beneficiaries of the engine. The engine itself is the star, and the more we study it, the more we realize how robust it is. The black smokers, The violent volcanic vents are short-lived. They might last for a few decades before the magma chamber shifts or the volcano goes dormant. They are flashy but fleeting. But the lost city, because it relies on the slow, steady hydration of the mantle, a single field can last for hundreds of thousands of years. It provides a stable, long-term home for chemistry to experiment. It gives lifetimes time asterisk. Time is the one thing you need when you are trying to turn a molecule into a microbe, and the lost city provides it in abundance. But this stability brings another terrifying thought. If this process is so stable, so fundamental, and requires only rock and water, then it is not unique to Earth. Between 2011 and 2017, as our space probes sent back data from the outer solar system, the connection became impossible to ignore. We looked at Enceladus, the icy moon of Saturn, spitting plumes of water into space. We looked at Europa, the frozen moon of Jupiter, and we realized that they too have rocky cores. They too have oceans of liquid water trapped beneath their ice. And they too almost certainly have serpentinization. The terrifying implication of the Genesis engine is that the universe might be teeming with lost cities. It implies that in the dark, sunless oceans of a dozen moons in our own solar system and a billion moons across the galaxy, these white towers are growing. They are churning out hydrogen. They are building proton gradients. They are creating the conditions for life. It transforms the dark, cold void of space into a potential nursery. It means that we are probably not alone. And while that sounds hopeful to some, to others it brings a crushing sense of mediocrity. If life is everywhere, then life is common. And if life is common, it is just another form of matter, another way the universe processes energy. But let's return to the specific dread that the lost city evokes in the researchers who hover over it. It is the dread of fragility. Because while the geological process is robust, the site itself is incredibly delicate. The white limestone structures are brittle. A clumsy move by a submersible could topple a tower that took 10,000 years to grow. And as human interest in deep-sea mining grows, as we scour the ocean floor for rare earth metals and resources, places like the lost city are at risk. We are contemplating destroying the library before we have even read the books. We are looking at the site that explains our existence, and we are wondering how much it is worth by the ounce. The chemistry of the lost city also challenges our definition of alive. When does a geological process become a biological one? The chemical reactions inside the vents are organized. They sustain a cycle. They use energy to build complexity. In a dark, abstract way, the field itself behaves like a living organism. It breathes in seawater. It exhales hydrogen. It grows. It repairs itself. Standing at that blurry line between a rock and a cell, the researchers felt the ground shifting beneath their feet. They realized that the categorization of life versus non-life might be a human invention, a line we draw in the sand that nature doesn't recognize. The Genesis engine suggests a continuum. The rock becomes the vent becomes the chemistry becomes the cell becomes the fish becomes the human. It is all one long, unbroken chain of energy dissipation. And what happens when you stare at that chain too long? You start to lose your sense of self. You stop seeing yourself as a person with a name and a history, and you start seeing yourself as a collection of redox reactions. You start to see your own body as a portable vent, carrying your own internal ocean, maintaining your own proton gradients, desperate to keep the flame lit. The terror is existential. It is the feeling of being reduced to your component parts, of seeing the wires and the gears behind the illusion of consciousness. The fluids at the lost city are invisible until they hit the open water. When the alkaline water exits the chimney, it shimmers. It looks like heat haze on a highway in summer. That shimmering is the mixing of two worlds, the world of the rock and the world of the ocean. And it is in that mixing zone that the magic happens. Researchers found that the conditions there are perfect for the formation of fatty acids, the molecules that make up cell membranes. They found that the mineral walls contain iron and sulfur clusters that look almost identical to the active centers of enzymes found in modern cells. It is as if the rock invented the engine parts and life simply adopted them. This creates a haunting narrative for the origin of life. It suggests that we did not claw our way out of the mud. We were extruded from the rock. We are the children of the mantle, and for billions of years, our ancestors were stuck. They were locked in those rocky towers, unable to leave, because they needed the natural proton gradient of the vent to survive. They were the rock-bound phase of life. It took eons for them to invent their own portable pumps, their own membranes, allowing them to break free from the chimney and float into the ocean. The Lost City is a monument to that liberation. It is the house we grew up in, the house we had to leave to become who we are. There is a silence to the Lost City that is different from the rest of the ocean. At a black smoker, you can hear the roar of the superheated water. It is violent and loud. But the Lost City is a place of seepage. The water percolates. It whispers. It is a slow, steady exhalation. And that slowness is deceptive. We are used to thinking of catastrophic events changing the world. Asteroids, volcanoes, earthquakes. But the Genesis engine works on the timescale of geology. It creates life not with a bang, but with 100 million years of quiet persistence. It reminds us that the most powerful forces in the universe are often the most patient. In 2015, a team drilled into the Atlantis Massif. They wanted to see what was happening deep beneath the vents. They brought up cores of serpentinized rock, cylinders of green stone that smelled faintly of damp earth and mystery. And inside those rocks, deep below the seafloor, they found evidence of microbial communities. Life wasn't just on the surface of the vents. It was inside the mountain. It was thriving in the microscopic cracks, kilometers down, living off the hydrogen produced by the cooling rock. This is the deep biosphere, an entire realm of life that exists within the crust of our planet, outweighing all the life in the oceans combined. And the Lost City is the surface expression of that hidden kingdom. It is the chimney for a furnace of life that burns deep underground. This realization forces us to look at the Earth differently. We usually think of life as a surface phenomenon, a thin layer of green paint on a blue rock. But the Lost City suggests that life might be more like a mold that permeates the crust, a rot that runs deep. It suggests that the planet itself is alive in a way we hadn't considered. The boundary between biology and geology dissolves. The Earth isn't just a platform for life. It is a participant. The serpentinization process connects the movement of the continents to the breath of the microbes. It ties the shifting of the tectonic plates to the beating of our hearts. But why does this terrify researchers? Why use such a strong word? Because it strips away the mystery in favor of mechanism. It replaces the divine spark with a chemical gradient. And for those who dedicate their lives to understanding the universe, finding the answer is always a little bit sad. It means the puzzle is solved. It means the magic trick is explained. When you realize that life is just a way for a planet to expend its chemical energy, it feels cold. It feels mechanical. It makes us feel small. And yet, there is a beauty in that mechanism. There is a grandeur in the idea that the universe is rigged in favor of life. That matter wants to wake up. The white towers of the Lost City stand as a testament to that desire. They are monuments to the stubbornness of matter, to the inevitability of complexity. They stand in the dark, year after year, century after century, pouring their shimmering fluids into the abyss, building their cathedrals of limestone, waiting for us to notice. The research conducted between 2011 and 2017 didn't just map a vent field, it mapped a possibility space. It showed us that the origin of life wasn't a freak accident in a soup, but a structured, powered, geological necessity. It shifted the paradigm from life is rare to life is expected. And in doing so, it made the universe feel both more crowded and more lonely. Crowded because we now know where to look for neighbors. Lonely because we know that they too are likely just the product of wet rocks cooling down in the dark. As we drift away from the lost city in our imagination, letting the lights of the submersible fade, we leave the white towers behind in the crushing dark. We return to the surface, to the air, to the sunlight. But we carry the knowledge with us. The knowledge that deep below, the engine is still running, the serpent is still eating the rock, the hydrogen is still rising, and the chemistry that made us is still dancing across the thin, fragile walls of stone, creating the potential for life over and over again. It is a process that doesn't care if we watch. It doesn't care if we understand. It just continues. The Genesis engine is terrifying because it works. It is terrifying because it is simple, and it is terrifying because it is still there, down in the blackness, doing exactly what it has done for 4 billion years. It is the heartbeat of the planet, a slow, alkaline rhythm that beats in time with the cooling of the crust. And as long as there is water and rock, that heart will keep beating. The abyss is not empty. It is full of the potential for everything. And that is a weight that is hard to carry. This brings us to a strange paradox of the deep. The conditions that created us are lethal to us now. If you were to swim in the fluids of the lost city, the high pH would burn your skin. The lack of oxygen would suffocate you. The pressure would crush you. The cradle has become a grave. We have evolved so far from our origins that we can no longer touch them. We can only look through the glass of our machines, separated by millions of years of adaptation. We are exiles from the deep, returning to visit a home that no longer recognizes us. The white towers are ghosts. They are ghosts of the Hadean earth. They are time machines that allow us to witness the moment when the inanimate became the animate. And like all ghosts, they haunt us. They whisper to us about where we came from, and they hint at where we might go. They tell us that we are made of star stuff. Yes, but also of sea stuff and rock stuff. They tell us that we are the children of the vent. And so, the lost city remains one of the most significant and unsettling discoveries in the history of science. It sits there on the Atlantis Massif, silent and white, a riddle wrapped in limestone. It challenges our exceptionalism. It rewrites our history. And it points a finger at the stars and says, "Look there, it is happening there too." It is the ultimate decentralization of humanity. We are not the center of the universe. We are not even the center of our own planet's biological history. We are just the leaves on a tree whose roots go down into the mantle, deep into the dark, where the water burns the rock and the rock breathes life into the water. The fear it instills is the fear of the sublime, the awe that comes from understanding something so vast and so old that it cannot be fully comprehended by the human mind. It is the terror of looking at a machine that built you, and in the silence of the deep ocean, that machine hums on, indifferent, efficient, and eternal. It is the Genesis engine, and it is waiting for us to understand just how powerful it really is. But understanding brings its own burdens. Once you see the engine, you cannot unsee it. You see it in every glass of water, in every stone, in every breath you take. You realize that the separation between you and the earth is an illusion. You are a walking, talking piece of geology. And as you lay in bed tonight, listening to the wind or the traffic or the silence of your own home, remember the white towers in the dark. Remember the shimmering fluids. Remember the hydrogen bubbles rising to the ceiling of the world. And remember that deep down, in the cold and the dark, the earth is still creating. It never stopped. And perhaps it never will. The story of the lost city is not just a story about the past. It is a story about the persistence of life's potential. It forces us to ask what else is hiding in the dark. If we missed this for so long, If we misunderstood the very mechanism of our own creation until just a few years ago? What other engines are churning away beneath the waves? What other secrets are locked in the pressure and the cold? The ocean is vast, and our lights are small. We have seen the white towers, but we do not know what lies beyond them. We do not know what other experiments the earth is running in the privacy of the deep, and that is the final thought that lingers. The idea that we are not the end product. We are just one result of the engine. The lost city has been running for eons, and it will run for eons more. Who knows what else it will create? Who knows what other forms of life might rise from the vents in the distant future, long after we are gone? The engine is patient. It has all the time in the world, and in the silence of the Atlantis Massif, it continues its work, building the future one molecule at a time. The terrifying thing isn't that we came from there. The terrifying thing is that we are just one of many things that could. So when researchers look at the data from 2011 to 2017, they don't just see numbers. They see the inevitability of biology. They see a universe rigged for life. And they see the lost city for what it truly is. Not a ruin, but a factory. A factory that has been open for business since the dawn of time. And the lights are still on. In the middle of the Atlantic Ocean, far beneath the surface where the waves break and the sunlight fades into an endless, crushing indigo, there stands a city. It is not built of brick or steel, and it was not raised by human hands. It is a metropolis of white limestone, a cluster of ghostly spires rising from the seafloor like wax dripping from a candle that has burned for 100,000 years. This is the lost city, and since its discovery, it has been a scientific curiosity, a geological oddity, a beautiful anomaly in the dark. But in recent years, specifically as we move through 2018 and into the present day, the way we look at this silent white city has changed. It has stopped being merely a place on a map and started becoming a mirror. And when researchers look into that mirror now, they do not just see the bottom of Earth's ocean, they see the rest of the universe staring back. To understand why this place haunts the dreams of astrobiologists, you have to understand what it isn't. It isn't like the violent black smokers found elsewhere along the mid-ocean ridges, those roaring chimneys that spew superheated, acidic water filled with heavy metals. The lost city is quiet. It is gentle. It is alkaline. Here, the mantle of the earth reacts with seawater in a process called serpentinization. It is a chemical embrace between rock and water that produces heat, produces hydrogen, and produces the very building blocks of life itself. And it does so in the dark, without a single photon of sunlight, sustained only by the chemistry of the planet itself. For decades, this was just fascinating geology. But around 2018, as data from the Cassini mission to Saturn began to be fully digested and plans for the Europa Clipper mission began to solidify, the context shifted. We stopped looking at the lost city as a local phenomenon and realized it was a cosmic blueprint. We realized that if you stripped away the Earth's atmosphere, stripped away the continents, and looked only at the chemistry occurring in the dark of the Atlantis Massif, you were looking at the exact same conditions believed to exist on Enceladus. You were looking at the subsurface ocean of Europa. The realization is both thrilling and terrifying. It means that the best laboratory we have for understanding alien life is not a computer simulation or a sterile room at NASA. It is right here, sitting quietly in the Atlantic. It means that the white towers of the lost city are the closest we can get to walking on the floor of an alien ocean without leaving our own planet. And it means that if we want to know if we are alone in the universe, we don't necessarily need to look up. We need to look down. But just as this cosmic connection was coming into sharp focus, just as we began to understand the profound fragility of this timeline, another shadow fell across the water, a shadow cast not by clouds or waves, but by industry. Because the same geological processes that create these cathedrals of limestone, the same chemical reactions that might have sparked the first life on Earth, also concentrate metals, rare earth elements, zinc, copper, cobalt, the materials that power our smartphones, our electric cars, and our modern lives. And so, the narrative of the Lost City shifted from one of pure exploration to one of urgent, desperate defense, because the ocean floor is no longer a sanctuary. It is a frontier for mining. Imagine a machine the size of a 2-story house. It weighs nearly as much as a blue whale. It is built of reinforced steel, designed to withstand pressures that would crush a human being instantly. It moves on tank treads that grind the seafloor into dust. It is equipped with cutter heads, massive rotating teeth designed to chew through rock and sediment to harvest the nodules and crusts that lay scattered across the seabed. This is not science fiction. These machines exist. They are parked in warehouses and tested in shallow waters, waiting for the green light to descend. In 2018, the threat moved from theoretical to imminent. The International Seabed Authority, the body tasked with managing the world's ocean floor, began granting exploration contracts for deep-sea mining. And one of those contracts, granted to Poland, covers a patch of the mid-Atlantic ridge, a patch that sits perilously close to the Lost City. This is where the terror sets in for the researchers. It isn't just the fear of a machine physically crushing the spires, though that would be a tragedy akin to bulldozing the pyramids to build a parking lot. It is the fear of the plume. When you grind rock underwater, you create clouds of sediment. Fine, silty dust that hangs in the water column, drifting with the currents. In the deep ocean, the water is crystal clear. The organisms that live there, the sponges, the corals, the tiny microbial mats that cling to the limestone chimneys, they have evolved in stillness. They are filter feeders. They breathe the water. If a mining operation begins even kilometers away, those plumes can drift. They can settle over the white towers like a suffocating blanket. They can clog the delicate pores of the sponges. They can smother the microbial communities that have thrived there for 100,000 years. We wouldn't even have to touch the city to kill it. We could destroy it simply by being neighbors. There is a profound irony here, a bitter paradox that keeps scientists awake at night. We are desperate to mine these metals to build the batteries that will wean us off fossil fuels. We want to save the planet's atmosphere by harvesting its depths. We want to stop the warming of the climate by tearing up the seafloor. We are willing to risk destroying the very cradle of life, the only place on Earth that shows us how biology can emerge from stone, in order to power the devices we use to talk about saving nature. And the timing could not be worse. Just as our technology has advanced enough to truly study the Lost City, to send autonomous vehicles into its deepest crevices, to sequence the DNA of the microbes living inside the rock, our technology has also advanced enough to destroy it. It is a race between understanding and exploitation. And at the moment, exploitation has the momentum. The researchers who visit the site now describe a feeling of preemptive grief when they descend in submersibles, peering out through thick acrylic viewports at the ghostly white landscape. They are not just taking notes. They are bearing witness. They are mapping every centimeter, sampling every fluid, recording every chemical gradient, driven by the gnawing fear that they might be the last generation to see it intact. They are trying to read the books in the Library of Alexandria while they can smell the smoke of the approaching fires. The tension is palpable in the scientific literature published over the last few years. Papers aren't just reporting data anymore. They are pleading. They are arguing for the Lost City to be designated a World Heritage Site, a protected zone where no treads can grind and no cutters can spin. But the high seas are a lawless place, or at least a place where the laws are written in shifting sand. The jurisdiction is complex. The economic incentives are massive. And the Lost City, for all its scientific value, does not have a voice. It cannot sue for protection. It cannot protest. It can only stand there, white and silent in the dark, as the machines draw closer. Let's go back to that idea of the mirror. The reason the Lost City terrifies researchers isn't just because it might be destroyed. It is because of what its destruction would say about us. If we are willing to crush the one place on Earth that tells us where we came from. If we are willing to sacrifice the one environment that can teach us about life on Europa or Enceladus, then what does that mean for our future in space? If we find life on an icy moon, will we study it, or will we mine the ice? If we find a new biology in the dark, will we revere it, or will we consume it? The Lost City is the test case. It is the moment where humanity has to decide what matters more, the commodity or the curiosity. In the last 5 years, the rhetoric has sharpened. Deep-sea biologists have begun to sound like prophets of doom. They speak of irreversible loss. They speak of extinction events, caused not by asteroids, but by corporate spreadsheets. They describe the deep ocean not as a resource, but as a biological archive, a library of life that we haven't even catalogued yet. And amidst this geopolitical and economic storm, the city itself remains indifferent. That is the haunting part. The limestone chimneys do not care about the International Seabed Authority. The microbial mats do not care about the price of cobalt. They continue to do what they have done for millennia. They bubble, they vent, they turn rock into energy. They support a fragile, alien ecosystem of snails and crabs and transparent shrimp that live their entire lives in the glow of chemical reactions, utterly unaware that a species living in the sunlight miles above is debating their right to exist. We look at the Lost City and we see a fragile anomaly. But perhaps the city looks at us, if it could look, and sees the anomaly, a species that burns its own home and then comes looking for new fuel in the foundation. The connection to space makes this even more visceral. When NASA plans a mission to Europa, they spend years, billions of dollars, developing sterilization protocols. They bake their spacecraft. They scrub every surface. They are terrified of introducing a single Earth bacteria to an alien ocean because they know that contamination would ruin the science forever. We treat the potential life on Europa with sacred reverence. We treat the potential life on Enceladus as precious beyond measure. Yet here on Earth, at the Lost City, which is the exact same environment, we are debating how close we can park a bulldozer. We are willing to protect the simulation, but not the reality. We are willing to spend billions to find life out there, while we sign contracts to bury it down here. This dissonance is what weighs on the minds of the people who know this place best. It creates a sense of vertigo. You are looking at a chimney that is 30,000 years old. You are looking at water that has been trapped in the mantle for millions of years. And you are realizing that a single week of industrial activity could turn it all into a graveyard of silt. The silence of the Lost City is heavy. It is the silence of age, of patience, of deep time. But the silence that threatens it now is different. It is the silence of an empty room, the silence of an erased history. As we move forward, the question remains unanswered. Will the Lost City survive the coming decade? Will it remain a pristine laboratory for the study of life's origins, a gateway to the stars sitting on our own ocean floor? Or will it become just another mine, another scarred patch of seabed where the white towers once stood? The researchers continue their work. They deploy their ROVs. They collect their samples. They write their papers. But every time they pull their instruments out of the water, every time the lights of the submersible fade into the blackness as they ascend, they have to wonder if they are leaving the city to its peace or leaving it to its execution. Because the darkness down there is not empty. It is full of answers. Answers about how we began. Answers about where else life might be hiding in the universe. Answers about the resilience of biology in the face of the impossible. But answers are fragile things. They can be broken. They can be buried. And once they are gone, no amount of technology, no amount of regret, and no amount of money can bring them back. The mirror is still intact, for now. We can still see ourselves in it. We can still see the reflection of Europa and Enceladus. But the hammer is raised, and the hand holding it is ours. In the end, the story of the Lost City in the 21st century is not just about geology or biology. It is about restraint. It is about whether we have the wisdom to leave something untouched. It is about whether we can look at a treasure and decide not to loot it. The hydrothermal field has survived ice ages. It has survived the shifting of tectonic plates. It has survived changes in ocean chemistry that wiped out 90% of life on Earth. But it has never had to survive us. And that, more than the pressure, more than the darkness, more than the alien nature of the life that lives there, is why it terrifies us. Because we know what we are capable of. We know that we are the only force on this planet that can look at a miracle and see a product. And as the demand for batteries grows, as the ice melts, and as the pressure to mine the deep sea mounts, the white towers of the lost city stand as a silent test. A test we are dangerously close to failing. For 120,000 years, the white towers of the lost city have stood in the dark. They were rising from the seabed before human beings had written a single word. They were exhaling their warm alkaline breath into the ocean before the pyramids were built, before the ice ages came and went, before we learned to master fire or forge steel. They have stood in silence, building themselves molecule by molecule, layer by layer, creating a cathedral of limestone that hosts a biology so unique, so ancient, and so isolated that it defies almost everything we thought we knew about life on Earth. And in all that time, through earthquakes, shifting currents, and the slow drift of continents, they have remained untouched. Until now, there is a terrible, quiet irony waiting for us at the bottom of the Atlantic. The very chemistry that created these spires, the serpentinization that turns rock into energy and builds these ghostly white chimneys, has also enriched the mantle beneath them. The seabed here is not just a biological wonder. It is a treasure chest. It is rich in rare earth metals, in zinc, in copper, in the very materials humanity is desperate to consume. We need them for our batteries. We need them for our phones. We need them, paradoxically, for the green technologies we hope will save our own atmosphere from collapse. And so, the oldest living ecosystem on Earth, a place that has survived isolation for over 100 millennia, is now threatened by the youngest species on the planet. We stand on the precipice of a decision that cannot be undone. To strip mine the seafloor here would be like burning down the Library of Alexandria to keep ourselves warm for a single night. We would gain the raw materials, yes. We would fill the cargo holds of our ships and power our cities. But in doing so, we would crush a history that was written in stone and water long before we existed. The towers of the lost city are not like the black smokers found elsewhere, those rugged chimneys of iron and sulfur that grow back quickly. These structures are made of carbonate. They are brittle. They are delicate. They are ghosts, made of chalk. A single pass of a mining dredge, a colossal machine built to chew through the crust of the planet, would not just damage them, it would erase them. It would turn 100,000 years of geological patience into a cloud of dust drifting in the current. And with that dust would go the secrets of how life might have begun on this planet. It forces us to confront a question that is uncomfortable, heavy, and deeply necessary. What is the value of a place that no human eye was ever meant to see? Does it matter if a tube worm lives or dies in the dark? Does it matter if a microbial mat, feasting on hydrogen in the cold silence of the deep, is scraped away to build a better smartphone? If we look at the lost city only as a resource, as a collection of minerals waiting to be harvested, then the answer is simple. But if we look at it as a relative, as an ancestor, as the last remaining echo of the chemistry that birthed us, then the destruction of this place becomes a tragedy of cosmic proportions. It represents the erasure of our own origin story. It is a reminder that for all our technology, for all our satellites mapping the surface, and our submersibles piercing the depths, we are still a clumsy species. We break things we do not understand. We consume things we cannot replace. The ocean has always been a place of forgetting. It swallows ships, it swallows cities, and eventually it swallows history. But the lost city has refused to be forgotten. It has held its ground against the crushing pressure and the endless dark. maintaining a fragile equilibrium that has outlasted empires. But it cannot outlast us. It cannot survive the sheer mechanical weight of human ambition. As we stare at the footage of these spectral towers, glowing faintly in the lights of our robotic probes, we are left with a feeling that is hard to name. It is not quite fear, and it is not quite wonder. It is a sense of dread mixed with awe, a realization that something so ancient can be so easily destroyed. It reminds us that deep time is resilient, but it is not invincible. The earth is old, but its memories are fragile, and once they are broken, they do not heal. They simply vanish into the water, leaving behind only the silence that was there before. But this story, the story of life thriving in the dark, fueled by chemical fire and hidden beneath a frozen or watery shell, does not end here in the Atlantic. The Lost City is just one chapter, one local example of a phenomenon that might be far more common than we ever dared to dream. If life can cling to a vent in the crushing depths of our own ocean, surviving on nothing but rock and water, then it is almost certainly waiting for us elsewhere. There is another ocean, far deeper and far darker than the Atlantic, locked beneath a crust of ice miles thick. It circles a giant planet, pulled by tides that generate heat in a cold vacuum. It has the water, it has the energy, it has the time, and if the Lost City teaches us anything, it is that life finds a way to endure in the dark. If you want to know what might be swimming in the black oceans of Jupiter's moon, Europa, and why NASA is terrified of contaminating it, you need to watch this video next.